Hello, everyone. This is Ellie Crumples from the Cognition IP team. It is my pleasure to welcome you to today's webinar, Patenting AI and Other Software Innovations. Before we get started, I want to go over just a couple of housekeeping reminders. First, we will be muting everyone upon entry. We do that to avoid background noise and disruptions during the presentation. But even though we've muted you, we do want this to be an interactive session. So please feel free to drop your questions and comments into the chat box throughout the presentation, and we'll save time to tackle those at the end during our Q&A section. Finally, a friendly reminder that this session is being recorded, and you will receive a follow-up email with the session recording from me tomorrow. And now it's my pleasure to introduce Arun Karuna. Arun is a patent attorney at Cognition IP with over 12 years of experience. Arun crafts IP strategies and builds patent portfolios for a variety of startups and established tech companies. In his career, Arun has prepared and prosecuted patent applications for startup companies covering a broad range of fields, including web technologies, blockchain, cryptocurrency, AI, machine learning, computer vision, autonomous vehicles, AR, VR, robotics, database management, social media and advertising, streaming media, medical devices, wearables, mobile technology, networking, and digital security. And now, without further ado, I'll hand it over to Arun.
Thanks, Ellie. Hi, everyone, and thanks for coming to this webinar. Today, we'll be talking about patenting AI and other software innovations. It's a really exciting time to be discussing this topic. There has never been as feverish activity in AI and similar technologies as right this very moment. And as we'll see in the presentation, that will be borne out because AI is the most active and most filed and applied for technology currently within the US Patent Office, at least. So a very exciting time, a lot of activity happening. The downside potentially is that it might be a bit of a crowded field depending on what you're trying to patent. And we can talk about that a bit later. But trying to find a good patentable invention and moving forward with it is certainly possible and certainly worth talking about. So we'll do a bit of that today. A bit of an overview of what we'll be discussing today. First, we'll be talking about the types of IP applicable to AI and software startups. I won't be discussing copyright, but I will be discussing patent and trademark rights generally. Copyright is a pretty big issue and can be its own topic in itself. Landscape of innovators in the AI and software industry. We'll be discussing some of the main players here and the people who have the most activity and what their technology might look like. And then we'll be discussing trends on patent filings related to AI, software, and systems, and then challenges related to patenting AI and similar software technologies, as well as strategies for overcoming them. And then finally, we'll get into a Q&A. So first, types of IP applicable to AI and software startups. And as I mentioned, I'll be talking about patents and trademarks, but not copyrights this time. So number one, what is a patent? A patent is a legal monopoly to prevent others from making, using, or selling your invention. And it's not an affirmative right to do something. Instead, it's a right to prevent others from doing something. It has a 20-year term upon your patent being granted, and it's granted by the US Patent Office after an application examination process. So that examination process could, it generally does take several years unless you have a prioritized examination process that you pay an extra fee for, which is called a Track 1 filing. But yes, it can be quite a long time for this examination process to occur. And it generally involves a lot of back and forth between the examiner and you or your attorney, in which you make the case that your invention is patentably differentiable from other inventions that have gone before and other literature and things of that nature. How do you patent something? Well, you file a patent application. You do this by describing the invention in a very detailed manner. And then you, also the idea stage is okay. So you do not necessarily need a prototype. If you have one, that's great, but you can have a patent on something that you do not have currently working. What are the requirements for filing a patent application? It has to be new, not obvious, and sufficiently detailed such that someone skilled in the field could make the invention. And here we're talking about the application and how it's prepared. So an examiner will be looking very carefully at the application you've filed to make sure that it's talking about something new and that it's not obvious based on the prior art that has come before, and that you've described it in a sufficiently detailed way so that if anyone who is generally an expert in the field reads it, they would have a decent idea of how they could make it themselves. Number two, trade secrets. So these are neither publicly recognized nor registered with the government. So that's a big contrast from patent rights. Also, their term is potentially forever rather than merely 20 years. Trade secrets do not protect against inventions made public, reverse engineering, or independent invention. So let's talk a bit about that. Inventions made public. So if you have disclosed your idea, either in a conference or with investors without an NDA signed, or you've had some potential partners who you've discussed it with, and then they've gone back and talked about it with other people, those are all considered inventions that have become public. So once you've done that, then you can no longer claim that you have a trade secret on something. As far as reverse engineering goes, if you have a formula that you put on the market and someone else can do a chemical analysis to determine what it is, then your trade secret would not be effective to prevent that. In a software context, that might mean having the open source software code available, or generally just describing how an invention is made or how a software program is created to such an extent that you would not be able to claim trade secrets on it. Independent invention, by this we mean that a patent will prevent others from practicing your invention, even if they came up with it independently, whereas a trade secret will not do that. So it will only protect against things like misappropriation of your trade secrets, such as an employee taking away your secret or industrial espionage. A trade secret, by definition, is any information that has independent economic value and is not generally known or ascertainable. By independent economic value, we're talking about independent of any intrinsic value of the information. So would a potential competitor or other interested person have to expend time or money to find or develop this information? And not generally known or ascertainable, by this we mean the public or competitors or other persons in the industry. If even knowledge by a very small number of outsiders can deny or destroy this trade secret status, then you cannot claim that you have a trade secret on it. So you must exercise reasonable efforts to maintain this secrecy. Merely the desire or intent to keep information secret would not be enough for trade secret. In the California federal court, reasonable efforts could include things like advising employees of the existence of a trade secret, limiting access to the info on a need-to-know basis, requiring signing of NDAs or confidentiality agreements, or keeping secret documents under physical or virtual lock. So now that we've briefly discussed both patents and trade secrets, excuse my dog, we come to the question of what is the difference between patents and trade secrets, and when should I patent something versus keeping it as a trade secret. First, we should consider user-facing or client-side processes. So you might want to consider patent protection if your AI model or your AI application has user-facing or client-side aspects to it. One example might be an AI chatbot, and we'll talk a bit about a Microsoft AI chatbot in some coming slides. And another example might be consensus-based anti-fraud detection for e-tickets, which might be something that relates to AI plus blockchain or something of that nature. On the other hand, you might want to consider trade secrets instead of patent protection if there are server-side features and information which are prominent to that invention. So underlying server-side optimization methods using AI might be an example, or specific machine learning or user personalization algorithms. One interesting example would be a Zillow trade secret suit that happened pretty recently. So Zillow is a company that created the first online real estate marketplace, and they claim that they've been able to maintain a competitive edge by investing in search relevance and user personalization technologies, including personalization algorithms, in order to provide a consumer experience that's far superior to their rivals. So in mid-2019, they filed a suit against a former senior director of machine learning, Robert Chen, and his new employer, Compass, for misappropriating, in other words, stealing, Zillow's machine learning, search relevance, and user personalization technologies. Zillow claimed that Compass, which is the country's fastest growing luxury real estate technology brokerage company, actively recruited Chen so that it could obtain Zillow's trade secret information. Now, notably, Zillow did not sue Compass and Chen for patent infringement, although they do have several patents relating to this AI technology. This reflects the reality that many companies have made significant advances in machine learning and AI algorithms, but they've chosen to protect certain aspects of those technologies with patents and other aspects through trade secret protection measures. So that just goes to show there are some technologies which you may want to seek out patent protection for, and there are other technologies you may want to keep as trade secrets. And deciding between the two, you can use some of these tips here as a guideline, but talking to a specialized attorney can be very useful for that as well. You might want to think about detectability and reverse engineering. So by detectability, we're talking about if detecting when a competitor uses an invention is hard, then the value of patenting that invention is diminished because it would be difficult to know that the patent is being infringed. This might be the case with innovative training algorithms for machine learning systems, for example. It's perhaps possible to detect that the ML system is being used, but it would be hard to detect how it was trained. Potentially, that suggests that trade secret route might be the way to go for such technology. For reverse engineering, if it's easy to reverse engineer that invention or hard to keep it secret, either due to a desire to publish or visibility of the invention in the product or something else, then the patent route might be preferable. It's worth noting also that it might be possible to delay deciding between patent or trade secret protection by filing a US patent application with a non-publication request. And that prevents your invention from becoming public unless and until you get a patent. So if during prosecution or examination, it turns out that the patent is difficult to obtain or that the allowed claims are so narrow that they have very little value, then the patent application might be abandoned by you without actually becoming public. So this could potentially strike a balance between secrecy and patentability. But the downside is that it eliminates the possibility of foreign patent protection if you were interested in getting patent protection in other countries. So coming to topic number 2, trends on patent filings related to AI software and open source systems. And I'll mostly be talking about patent rights as they relate to AI within the USPTO. So I'm just posting up a chart here. It's showing the volume and share of public AI patent applications from 1976 to 2018. So this figure was sourced directly from the US Patent Office. They came out with this in October of 2020. And it just illustrates the long-term trends from 1976 to 2018 with the volume of public AI-related patent applications. Because of changes recently made by the AIPA, or American Inventors Protection Act, which happened at the end of 1999, the trend from 2002 up to 2018 showed a significant increase in AI-related patent applications. So in the 16-year period from 2002 to 2018, annual AI-related patent applications increased by more than 100%, and they rose from 30,000 to more than 60,000. So pretty significant. And as you can see, there's quite a lot of activity in the AI space right now. The US Patent Office defines AI as consisting of one or more of 8 component technologies, which I can show you right here. This is also sourced from the USPTO. These components can include software, hardware, or applications, and any single patent document can contain multiple of such AI component technologies. So I'll just briefly talk about these 8 different component technologies, which might be included within an AI patent. So number 1, knowledge processing. This is representing and deriving facts about the world and using this information in automated systems. So for example, Intuit described an algorithm that uses a predefined knowledge base to automatically detect accounting errors. This would be used for real-time error detection for online income tax preparation. So great use of AI there for knowledge processing. Number 2, speech. Speech recognition can include techniques to understand a sequence of words within an acoustic signal. So obvious examples would be Apple's Siri, Amazon Alexa, or Microsoft's Cortana, AI which answers articulated questions and responds to spoken commands. Number 3, AI hardware. So these are physical computer components that are designed for AI purposes or to take advantage of AI through advanced computational processing, etc. For example, IBM patented a device that mimics synapses between biological neurons in order to process information efficiently, similar to a biological brain. Number 4, evolutionary computation. This contains a set of computational routines using aspects of nature and evolution specifically. So Chevron patented an evolutionary approach to predicting available petroleum reserves. The system evaluates a large number of competing models, then selects the model with the highest performance using a genetically inspired algorithm that mutates through different options. Number 5, natural language processing. This involves understanding and using data encoded in written language. And examples can include using text to build an ontology by simulating various human memory approaches, and then using that ontology to perform various tasks more efficiently. Number 6, machine learning. And this is obviously a big one. This is a pretty broad class of computational models that learn from data. So an example would be Walmart's patent that describes an algorithm to optimize an e-commerce platform by classifying product descriptions, reviews, and other product features using crowdsourcing in order to resolve ambiguous results. 7, vision. So computer vision is gaining huge popularity recently. It would be extracting and understanding information from images and videos. An obvious example would be the computer vision that's used in autonomous vehicles to identify objects and people within captured video from a camera. Number 8, planning and control. So this last one includes processes to identify, create, and execute activities to achieve specified goals. One example is a patent that detects potential problems in processing plants through environmental conditions, using an expert system to identify and address those problems. So I hope that gives you an idea with 8 different examples across those 8 different components for what people are patenting in those different areas and what the potentials might be. Another chart here, also from the USPTO, they separated out those 8 different components in terms of the volume of public AI patent applications by that AI component from 1990 until 2018. So the largest by a wide margin would be planning and control and knowledge processing, as you can see here. These are patents focused on controlling systems, developing plans, and processing information in various ways. They're the most general AI technologies. Usually, if there's an invention that involves machine learning, one of these two components is also involved. Worth noting that in recent years, computer vision and machine learning applications have really been on the rise. There have been a lot of recent technological developments in computer vision, which changed the trajectory for these sorts of patent filings, particularly for image recognition, as well as vision applications based on deep learning. AI hardware applications have increased as well. There's a close interplay between AI hardware and computer vision applications, which reflects the need for computational power and performance in demanding and resource-hungry computer vision tech. This specialized hardware could include accelerators for computer processors or specialized memory, as well as specialized hardware related to things like autonomous vehicles. Next, let's talk a bit about the landscape of innovators in the AI and software industry. This chart shows the top 20 owners of AI-related patents in terms of the number of applications granted. So at the top, you have IBM, and then Microsoft and Google, HP, Intel, AT&T, and then going down a bit further, you have Amazon, Apple, GE, and then down further, Qualcomm, Cisco, Sun, Adobe, Texas Instruments, and Yahoo, surprisingly, is still quite a large owner of AI patents. So this chart gives you a good overview of who the top players are right now in the AI space. Most of them are in the IT sector, but there are some exceptions, including GE. GE emphasized adding AI to its mechanical products and processes recently. So for example, they've been creating digital twins of jet engines to monitor and forecast maintenance issues. And they've also been building AI into part inspection more generally. I believe other players like Boeing also do similar, although they are in the top 30 rather than top 20, I believe. So IBM, as you can see in this, this news article here, they've topped the US patent list for the 28th consecutive year with quantum computing, AI, and hybrid cloud innovations. It says here that the IBM scientists and researchers received 9,130 US patents in 2020, the most of any company. So that gives you an idea of the #1 patent AI owner right now. So IBM received more than 2,300 AI patents in 2020. There's an interesting commercial offering that they released last year, which gained some buzz. It's Project Debater, and they call it the first AI system that can debate humans on complex topics. So what this system does is it digests massive amounts of text, then constructs a well-structured speech on a given topic, and delivers it with clarity and purpose. And they've actually tested this out in the field with actual debates in front of audiences or within video examples. And apparently it's done really well. It even cracks jokes, and it might exploit the audience's love towards children or things like that in order to make its points, which is quite impressive. This is, I'm not going to go into this in big detail, but this is a system diagram of all of the various components of that Project Debater. So the 4 main components are argument mining, an argument knowledge base, argument rebuttal, and the debate construction module. And each one of these has several different components within them. So even just within argument mining, you can see data from a corpus of about 400 million articles, corpus cleaning, wikifycation, sentence level indexing, claim detection, evidence detection, stance detection, and various inputs and outputs for each of these modules. So, you can start to see how IBM has so many patents that have been granted just this year alone. when you look at a diagram like this, considering that you can get a patent not just on this entire idea as a single idea, but you can drill down into various components and innovations within those components. So even just, for example, that stance detection within the argument mining module might have its own patent on it. I haven't actually checked, and I don't actually know what this stance detection is, but you can just imagine that if there are advancements in how that stance detection is done that nobody else has done before, then it's certainly ripe for patenting. And we'll talk about a bit further about what might be patent eligible versus patent ineligible material. So another thing that was kind of eye-raising recently, Microsoft filed a patent for an AI chatbot that mimics dead people, and they filed this in January 2021. That's a sensational headline, and I'm sure the actual patent application words things very differently, but still quite interesting. So it could presumably mimic dead people, including your dead relatives. It would ingest data such as the dead person's images, video data, voice, social media posts, and digital messages. And then based on this, it would simulate human-like conversation with this person using voice commands or text messages. And then it could also replicate this person via 2D or even 3D models. You could also use the same technology to chat with a convincing version of yourself. It got some negative press, understandably, with more than a few people noting that the tech was the basis for an episode of Black Mirror, the dystopian sci-fi TV show. So moving on to number 4, challenges relating to patenting AI and similar software technologies, and some strategies for how to overcome them. First, we'll talk about the bad news, or what cannot be patented. So the USPTO says that you cannot patent a mathematical concept, a method of organizing human activity, or a mental process. These are all considered abstract concepts which cannot be patented. So a claim is ineligible if it recites math. Many examiners also take the position that AI or ML models are mathematical in nature. So it kind of follows then that you would not be able to directly patent an AI or ML algorithm just by itself. Now we'll get to the good news. What can be patented? There was recent guidance from 2019 from the USPTO that indicated that claims reciting mathematical concepts are patent eligible if those mathematical concepts are integrated into a practical application. So what does that mean exactly? In terms of your strategy for integrating math-based AI models into practical applications, you should be thinking about these 2 different steps. First, you should explain the technical problem that the AI or ML system addresses. In other words, how the invention arises in a technological context uniquely. You might want to consider describing in the specification how the invention improves upon the existing technology. In other words, claiming aspects of the solution to this technical problem. And you can do this by describing flaws in the conventional technology and then potential benefits of your invention, and by explaining how the key limitations of the claimed invention are absent in prior art and what has gone before, and how you've improved over that prior art. You should consider using technical terminology in the claims so that there is enough technical substance in the claim to help avoid the claim read on merely mental processes or steps. So the computer processor recited will not be considered technical enough by the USPTO to get out of that abstract territory, and you'll definitely need more. So bringing in more technical terminology is useful. You should also consider talking about interactions with hardware specifically, even if that certain hardware is not recited as a positive limitation. You should also consider reciting in claims how data or signals might be transformed into a new state. And also normal, typical garden variety activities, such as displaying something on a screen or printing something out or storing a result, those won't be given any weight in patent eligibility evaluation. And you'll definitely need something more than just those garden variety activities. So think about claiming much more sophisticated aspects of your invention. And you should also consider patenting user interface elements and functionality if that might be applicable to your invention. So these are some ways that you can demonstrate a solution to a technical problem. And just going into this a bit further, technological improvements and additional features to the technology which your AI model uniquely enables is what you should be going for. A few different examples of these, and the bold words here just emphasize the various improvements that are rooted in the computer technology. So first, an iteration process to improve a determined result over time. And specifically that over time part is important because you want to demonstrate that, that whole feedback from machine learning, for example. Training and updating or optimizing a computer model based on ongoing data gathering and analysis. So optimizing an efficiency over what has gone before is also very important, as well as new ideas for training computer models. More efficient techniques for extracting certain features of, for example, an audio or image file, processing, and then analyzing them to produce a less noisy audio signal, or identifying certain objects in an image, etc. And then more efficient techniques for things like training models. Next, I'll talk a bit about open source software because I think that's a unique challenge that many people have to deal with in AI. So there's a common misconception that open source software cannot be patented. But even if a software is licensed under an open source license, it can potentially be patented if the open source license does not prohibit patenting and the software otherwise meets conditions for patentability. So it's really important to look at what license has been chosen by whoever you're incorporating software from. And if that license allows for patenting, then you can potentially patent. But if it doesn't, like the GPL v2 and v3, for example, get into some thorny questions around patenting, then you might want to not patent or hold off on patenting. And why patent open source software specifically? There's defensive and offensive reasons. The defensive reason is that it provides a defense against someone else patenting that functionality and asserting the patent against the open source software. The offensive argument is that it proactively prevents someone from replicating that functionality of the open source software and licensing it under a proprietary license. You would want to do this also to increase the value of your business and make investing in it more attractive. So some good reasons here to consider patenting your invention, even if it is open sourced by you. A bit about establishing an IP budget, because I also know that this is quite a challenge for many people. You want to figure out what your goals and motivations are for your IP, and you want to figure out how to achieve those goals based on limitations of your budget. By goals and motivations, I mean things like, are you trying to increase investor interest, or are you preventing specific competitors? So there's just a short list here. You might want to lock down your core foundational technology of your company, or lock down key high-value applications built upon that core. You might want to use it as a defensive shield to prevent others from suing you. Or you might want to just simply future-proof and acquire patents to bulwark against potential future risks. So these are potential goals, but you should have your goals in mind and have a good idea of what you want to do. And then if you communicate that to an IP firm or attorney, then they'll be able to do much more knowing your motivations. You should think about how much of your budget should be devoted to patents versus engineering, development, R&D, etc. And some useful gut checks here. For pre-seed and seed stage startups, roughly 5% should be going towards patenting. So for example, that might be 100,000 out of a $2 million total budget. For later stage startups, you should think about roughly 2 to 5%. And for established or publicly traded companies, it's not really about a percentage. It's just generally thinking, are all your bases covered, and what do your competitors' portfolios look like? How do you manage an IP firm and keep them within a budget? You should ask about fixed fees or a fee cap, because hourly billing can lead to big surprises. So fixed fees are generally where the industry has been heading and where Cognition IP generally focuses on. Uh, you should ask also about fixed fees for reporting emails and notifications, because there are some potentially hidden costs there. And if the emails and notifications are just included within a big fixed fee, then that might be potentially more transparent for you. Ask about exact costs for non-provisionals and PCTs, for example. Hidden fees might be things like low-cost provisionals that are followed by a high-cost conversion to a full non-provisional application. So you should think about different hidden fees like that and think about asking them about it. You should also ask who is going to be writing the application. So would it be an experienced lawyer or a junior associate? Is it someone who's experienced and knowledgeable in the technical matter or not? Things of that nature. Also, is the firm aware of and willing to shape filing and prosecution strategy in line with your stated goals and motivations, as well as your budget limitations? And I think that's a pretty key one, because once you've established your own budget limitations, whichever firm you choose should really be respectful of that and be willing to stick within it and work within it, no matter what those limitations are. As an IP firm, so Cognition IP just offers fixed fees throughout. We have transparent and predictable billing models. And also our legal team has significant computer science and AI related knowledge, which we can bring to that subject matter. A bit about money for inventions. So you just want to promote a culture of IP at your company. That's just generally crucial, whether you're a startup or a big established company. You want to have teams, including engineers and managers, understand the value and necessity of protecting IP. And you want education on an ongoing and periodic basis. Possible incentives, either financial or just simply recognition for team members, can be huge. These are people who take the time and energy to write up disclosures for patents and sit down with patent counsel and explain the concepts and review and provide feedback for applications before they're filed, et cetera. So rewarding them in some way can really increase the interest and excitement around IP at your company. You want to consider regular checkup meetings with each development team to capture IP. And you want to consider things like brainstorming sessions. I can't tell you the number of times when I've walked into a room where everyone was like, well, we don't have any new IP, but then you get their brains going and you get talking about some of the different ideas that might be coming down the pipeline and different spin-offs of those ideas. And then suddenly all kinds of new IP gets generated. And you can file on that because, as I mentioned, you don't necessarily need a prototype. You just have to have a good idea of how that can be implemented. And lastly, you want to have or consider a patent committee for evaluating patent disclosures and the feasibility of incoming patent ideas based on several criteria. So overall takeaways here. You want to think about patents versus trade secrets. And things to consider include detectability of infringement, ease of reverse engineering, and what cost it would be to you for the information to go public. You want to focus on patenting your core tech and its key applications. And so you don't want to focus on just merely patenting a mathematical AI model, but you want to think about the applications of that model and the different steps and improvements and solutions around that. And yeah, you want to talk about that going into number 3, the tech solutions to technological problems, improvements that are rooted specifically in computer technology. These are much more likely to be patent eligible. And open source is not necessarily a deterrent to protection, so you should still consider patent protection even on open source technology. For your budget, you want to budget based on realistic IP goals and ask the right questions. and you want to start creating a culture of IP at your company right now. So that's it for that presentation. Next, we'll be going into some questions and answers, as well as just general comments if you have any. So I'll let Ellie just take it away from here.
Sure. Thank you so much, Arun. So at this point in time, we will open it up for questions. If you have any burning questions, please feel free to drop them into the chat box. We also have a list of questions that came in with your registrations. So I'm going to just jump right in right away and tackle some of those. So one of the questions that came in was, someone would like to know, when is the right time to look into IP? Can you tell us more about that, Arun?
Yeah, so the simplest answer and the overly reductive answer is as soon as possible. The earlier you look into IP, the better. And in one way, another way to phrase this question might be, what seed round do investors expect you to have your IP sorted out by? Because for early stage startups, what investors expect from you in terms of IP is often very critical. So at the seed round, investors would expect you to at least have an IP plan if you're at least in an IP intensive business. If your company is based on IP at its core, then you should have a provisional or a non-provisional patent application filed at least by the time you've raised a seed round. The investors may also ask for things like a freedom to operate analysis or things like that. But in general, you should have at least one filed patent application at that point. And you can say that it's patent pending at that point as well, which you can tell investors, tell potential partners, tell whoever you'd like. It's never really too early to talk about IP and start considering IP, or at least thinking about what your goals might be and what your innovative core ideas, as well as your applications based on those core ideas might be.
Thanks, Arun. We had another question that came in. Moonlighting how to get a good IP setup at a small business full-time gig that may let me keep some IP rights.
Yeah, so I think the question is asking, how can you make sure that you have a good IP setup when you're working at a small business full-time and you want to keep some of your IP rights while working at that company? So this really gets into this question of your time versus company's time, and your IP versus company's IP. So it really depends on some of the contracts and agreements between you and that company. But generally speaking, at many companies, the work that you do during your day-to-day time at that job and the IP that you generate during that time is considered company IP. Whereas your independent projects and your independent time working on those projects outside of the company, as well as the IP generated from that time, is all considered, your time and your own IP. There are exceptions, and different contracts can include different stipulations there. But generally speaking, that's a good way to think about the division. And you want to make sure that probably it's complicated enough that you would want to contact an attorney to really sort out this issue for you before you make any serious moves. There have been some disasters, like what happens when you have already started at a company and you have some previous IP, and different people might own that IP, and how can you separate that from your current job? That, and once again, like separating your time from your company time. It's easy to say that and talk about that division in theory, but in practice, it can often get very messy because it's hard to know where your company's projects end and your independent projects begin. So I would advise consulting an attorney to really iron out those details and make sure everything is where it should be before you proceed.
Great, thanks, Arun. To tackle one of the questions that came into chat here, In a professional services company without any physical product sales, can patent protection prevent others from repeating a process without licensing it?
Repeating a process without licensing it. So I think what you're trying to ask is if there is a company which does not produce any ultimate product, such as an online service or anything of that nature, but instead has some underlying AI patentable technology potentially. Um, what would be the ramifications of the rights around patenting technology and licensing it out? So I would say that if it's on the back end and isn't highly visible to users or the outside world in any way, then you might want to consider this as a trade secret, as I had mentioned before in the presentation. So, that goes to those questions of detectability. If it's hard to detect and it's something that really keeps your business running in innovative ways, but that isn't necessarily outward facing, then it might be a ripe idea for a trade secret. But if you trade secret something, you can't really license it out by nature of what a trade secret is. So that's worth considering. If you do patent it, then you would be able to license out that technology to other people, but you would also lose those potential benefits of keeping that secret and keeping that confidential. And there might be other people who decide to take those general innovations that you have on your back end and exploit them for their own potential gain. So there are some trade-offs there, I think. Hopefully that gets to that question. Wasn't entirely clear on what the question was, but hopefully that helps you.
Thanks, Arun. Another question that came into chat here. There are a lot of cookie cutter AI architectures, for instance, inception models that can be used for a wide variety of applications like predicting home values, identifying plant species, etc. If you train a cookie cutter model on a new data set and vertical, what aspects of this would you think are the most defensible, if any, via patents?
Yeah, that's a pretty tricky question and a very good question. So you have some cookie cutter AI models, which can be trained on some well-known things like home values, for example, or predicting home values in the future. And you would like to take some of those cookie cutter models and train them on something entirely new or different or something unique that hasn't necessarily been done before. And you're asking what the patentability or patent value might be for patent protection there. It really, I think it depends on, it's a somewhat case-by-case basis, but just the fact that these are centrally based on cookie cutter models should give some slight pause there. And ultimately what really matters is what prior art has gone before. So if there has already been some known literature or a known product that's out there, or prior art patent applications or granted patents around that cookie cutter implementation of a pretty obvious utility, then simply using that same model for a different end might raise some issues with the patent examiners. And you might have a significant challenge trying to argue that what you're doing isn't obvious, because one thing that the examiners can talk about is obviousness, where they can say, okay, here's a prior art that does this thing. It would be obvious to take this thing and then do this new thing based on this prior art plus this other reference, which might be floating around. So they can combine two different references or three or four to get at your invention and then just say that it would be obvious based on those references. So this is where it gets very tricky. And this is one of the hardest things to overcome during that prosecution and examination phase, is how to overcome this charge of obviousness that the examiners have levied against you. And I think like for the cases that you're talking about, it might be somewhat hard to argue that. But again, it really depends on a case-by-case basis. And it depends on the specifics of what that technology is and what your new case might look like. So I think it would be worth talking to a patent attorney about this in particular, because they likely have some ideas based on the specifics of your case.
Great, thank you. To address one of the questions that came in during sign up, how can you patent AI when the algorithms are not patentable?
Yeah, how can you patent AI when the algorithms are not patentable? So we touched upon this a bit. As I had mentioned, the algorithms themselves are generally considered mathematical models by examiners. And mathematical models are generally considered unpatentable subject matter by the USPTO. So if you cannot patent mathematical AI algorithms, then what exactly can you patent about AI? And the answer is you can patent things like applications based on those models, which represent something of a technological solution to a technological problem. And by that, we mean, does it have an issue that is uniquely related to technology first? And then does it have some improvement or solution to that issue with technology that can only be solved using computer technology? That sounds a bit convoluted, but let's just talk about a brief example. So you might have a traffic issue where there's a highway with a lot of congested traffic, and you have an AI model that can analyze that traffic and then suggest different routes or change pricing of tollways based on the congestion of the traffic. So this would be uniquely a technological problem because the technology currently leads to huge congested traffic and lanes that are always backed up. And then this is a unique technological solution to that problem using an AI model to uniquely figure out which lanes might be more congested than others and figuring out what the pricing should be at a tollway to make that lane free up more. So that's just an example of the kinds of things that you would be able to patent. But you wouldn't be able to patent just, for example, a convolutional neural network or some variant of that without much changed. So, think about whether your idea would be abstract or obvious, and think about whether it's a mathematical model versus a more sophisticated application that's unique.
Great, thank you. Another question here, how should we combine or divide claims across AI and ML patent filings?
Yeah, so I think this question goes to whether you want to have multiple different patent filings around your AI or ML invention, um, and whether to combine claims into one invention or to divide them across multiple inventions or multiple applications. So the general principle here is you should properly separate out your inventions, or else the examiner will separate them out for you. So let's say that you have two distinct inventions and you want to save some money, so you want to only file one application with claims directed to both inventions. So you think this might be a good idea and that you can save a lot of money by doing this. And you try it, and for whatever reason, your attorney or firm says, okay, let's do it. You might receive, upon the first response from the examiner at the USPTO, a restriction requirement. And a restriction requirement means that the examiner has identified two or more inventions in your application, and the examiner is forcing you to choose one of those applications to proceed with. The other application or applications, you can potentially file a continuation off of those, and they can become their own patent applications. But the examiner will force you to, essentially, if you don't do it yourself. So generally speaking, it's a very good idea to have distinct inventions that are not too muddied and which can be clearly articulated per application. So one invention per one application is usually the way to go. That said, I know that there are different budgetary concerns, and if you have a very limited budget and a lot of things that you'd like to file on, there might be some ways to combine those. But generally, it's not a good idea to try to force that, because then you'll just end up back in the same place you were before, except the examiner will essentially choose your inventions for you rather than you being able to really carve them out exactly how you want. So hopefully that's helpful.
Thanks, Arun. One of the questions that's come into chat here. So if you can patent a specific application of an AI model, who would be considered the inventor if the user of the AI model that created the specific application is different from the creator of the AI model?
That's a very good question and very thorny, as you can imagine. So I think this is one of those things that the USPTO themselves has been trying to figure out. They recently, I think 2 years ago, solicited public comments around this question. So what they were specifically seeking comments on was this question of, if an AI creates a model completely based on its training, is that model then protectable, either as copyright or patent protection? And a lot of commenters came back with this idea that inventions should be necessarily human created and sourced from a human. The obvious rebuttal to that, though, would be that ultimately a human created the AI, which then created the model. So would that initial human own the patent rights and copyrights of that model, which was ultimately created? I think there's no clear answers to this yet. I'm not certain that the USPTO came upon a consensus on this question, but in general, I think ultimately the takeaway was that AI created models or frameworks or environments, anything, ultimately might be sourced back to the person who created that AI or the company who created that AI. It's probably not a set in stone rule or a bright line, and it's probably case by case, but that's generally my impression. But it's very much an open debate right now, and it's actually really fascinating to read more about that if you're curious about it.
Thank you so much, Arun. We are just at time now. I know there were several questions that were not addressed, but as a reminder, today's session was recorded. You will receive a follow-up email with a session recording from me tomorrow, and you can feel free to respond to that email and have any other burning questions that you may have addressed by our team. So right now, I would like to thank our presenter, Arun, so very much. And I would like to thank you all for joining and wish you a wonderful rest of your day. Thanks, everyone.